For this unit, we're talking about statistics. And in statistics, we really like data that follows a normal curve or a normal distribution. So normal curve or normal distribution is a curve where the data is symmetric or roughly symmetric. You'll never get perfectly symmetric data, but it's roughly symmetric, where the very middle of our data is the mean or the average of the data. Mean, we use this little symbol, it's called mu, to represent the mean of our data. And then the standard deviation, which is used with, or we use the notation with a little sigma to represent standard deviation. That is just talking about the typical variance between your data points. And that's something you don't really calculate. It's been pre-calculated for you, and so on. Now, when it comes to normal curves, they follow this very specific pattern. So just a reminder that this right here is the mean or the average right in the center. And then what we're doing is we're just adding iterations of the standard deviation to go to the right, and we're going to the left at subtracting deviations, standard deviations. If I talk about a z-score, which is rare, I'll mention it later on, but a z-score is just telling you how many standard deviations I've added or subtracted from the mean. So like this one would be a z-score of -3. This would be a z-score of -2, -1. This is right on the mean is 0, and then +1, +2, +3. And we only go 3 standard deviations to the left or right when we build these normal curves. Now, if a curve is normal, if you look at the values that are just 1 standard deviation from the mean, whether to the left or to the right, you'll get 68% of your data. That's actually also where we get this 34%. What we're doing is we're splitting that 68% in half to get the 34%. So each section right here underneath the curve would be 34% of our data. They found that normal curves also typically have 95% of our data between the 2 standard deviations. So right here is 95%. Now, to get these 13.5%, you'll notice this is not the same shaded, the area under the curve is not the same as the 34%. So the way we get that is we take the 95, we subtract 68 from 95, and then divide it by 2, and that gives you the 13.5%. Let me move those to the other side because we'll do some others in a second. The next one is 3 standard deviations. So right here, away from the mean, that gives you 99.7% of your data. The way we get these 2.35% is we go 99.7, we subtract the 95, so the ones that are 2 standard deviations away, and divide it by 2. And that gives you the 2.35%. And then last but not least, we get the 0.15% by doing 100%, or all the data, minus 99.7, and dividing that by 2. These other values, though, so that's kind of an understanding of where these smaller values are coming from. The other ones are just what they found as they studied statistics and looked at kind of typically what happened study by study. So we're going to go ahead and just work with this curve, these percentages. So I might ask a question like this where I say give the percent of area under the normal curve represented by the shaded region. So you'll notice the shaded region, if I look at it right here in my picture and compare it to this, I'm going from here to here. So I just need to add those 2 percentages together. So 34 plus 13.5, that gives me an answer of 47.5%. Okay, the next one, I'll erase this. The next one, we're going from negative, a z-score of -2, because we're subtracting 2, all the way to a z-score of -1. So that one, so that's 13.5%. And then we're adding it to this, and it looks like it's going on past 2 positive standard deviations. So we're going to add it to both the 2.35 and the 0.15. And just so I give myself some space, because I'm running out of room right there. There we go. I add all that together, I get 16%. And then let's go to the last one. The last one is from here to here, which would be like this to that one. So I'm going to take 2.35 and add it to the 13.5, which is 15.85%. So I'm just comparing it to the percentages I had before and just adding up all the percentages of the shaded region. Similarly, I might ask you to find the probability, but I won't give you the graph. I'll give you this information, kind of same idea. So I'm going from mu minus 2 all the way to mu, so that's this section, and they're just saying in between both of those lines. So it's the probability or percentage. So I'll go ahead and add those together, and that will give me 47.5% for that problem. Let's go to the second problem. Same idea, but this one's going just less than a value. There aren't two values I'm going to. So I'm going from here and they're saying less than, so I'm going below. So I'll add these 2% together. So I have 0.15 plus 2.35. When I add those, I get 2.5%. And then let's do the very last one. So this one is between two values. So I'm going mu minus sigma, so just this one right here. And then mu plus 3 sigma, which is right here. And I'm just going to add all of these in between. So we've got 34, and we're doing that twice, plus 13.5, plus 2.35. And then I add all that together, and then that will be my final answer. And if I add that, I get 83.85%.